Hello everyone, welcome to In 5 Minutes. In this video, we are going to see the problem on integration over a given volume. So this is our problem. Solve this integration over volume V, where V is volume enclosed within the three coordinates plane and the plane x plus y plus z equal to 1. What is the three coordinates plane? In three-dimensional, we have the three axes, that is x, y and z. And the coordinate plane is xy is one coordinate plane, yz is one coordinate plane, and xz is another coordinate plane. So one plane is this yz, one plane is yx, and one plane is xz. So these are the three planes. We have to find the volume V enclosed within this coordinate plane and the plane x plus y plus z equal to 1. What is x plus y plus z equal to 1 plane? So this plane has x, y and z term. This means that this plane is intersecting x-axis, y-axis and z-axis at some point. To find the point on x-axis, we will put y and z equal to 0. Then we get x equal to 1. So this plane is intersecting x-axis at x equal to 1. Similarly, when we put y and x equal to 0, we will get z equal to 1, and similarly we get this point. So this is our plane, x plus y plus z equal to 1. So we have to find the volume enclosed within this plane and the plane yz, this z, xy and this. That is, we have to cover this volume which is inside this plane. So that is the volume we have to cover. So as I have told you, whenever we have the volume problem, volume will have three limits. First limit for z, which will be the height of that volume. So height of this volume will be from this plane till this plane only, because we will consider a column parallel to z-axis. Always consider a column parallel to z-axis. So what is the lower end of this column? The lower end of this column is on the xy plane. Whenever we have xy plane, in that plane z is equal to 0. Why it is like this? When we have the coordinate axis, this is y-axis and this is x-axis. At every point on x-axis, y is equal to 0. And every point on y-axis, our x is equal to 0. Similarly, on every point on xy plane, our z is equal to 0. So these are the limits of z. And the upper limit of this column is on this plane, x plus y plus z equal to 1. So from this we get z equal to 1 minus x minus y. So this is our upper limit of z. So we get the height of the column, and we know that volume is area into height. So we get the limits for height. We have to find the limits for area. When we see this volume from upside in xy plane, we will get this triangle. So we will get this triangle. So we draw this triangle in xy plane. It is intersecting at 1, intersecting at 1. So let's say this is our y-axis and this is our x-axis. Now we will consider strip parallel to y-axis. So the lower end of the strip is on the x-axis, and the equation of x-axis is y equal to 0. And the upper end is on this line. What is this line? This line is nothing but from here we will get, this is the xy plane. So we have the line equation x plus y plus z equal to 1. This is the equation of plane. When we put z equal to 0 here, why we are putting z equal to 0? Because we are considering only xy plane. So we get x plus y equal to 1. This is the equation of this line. So this is how from one equation we will get multiple things. So from here we get y equal to 1 minus x. And we have to cover this entire region, because this is the region which we are moving this column. So we have to cover this entire region. So we will move this column from this point till this point. So here x is 0 and x is going till 1. So these are the limits of y and x. So our this integration will be integration of x going from 0 to 1, y going from 0 to 1 minus x, and z is going from 0 to 1 minus x minus y, and this term dx dy dz upon x plus y plus z the whole square. Now this is a simple integration. In this integration, if you see, first limit is for z and z is containing x and y. So the first integration will always be with respect to y. And second, here we have the x term in the limits of y. So second integration is with respect to y, and the third integration is with respect to x. Now if you also see here, these limits are nothing but limits of z, and which represents the height of this volume. and these limits are for area of this part. So we know that volume is nothing but area of base into height. So this is the area of base into height limit, then we can calculate the volume over this region.